Welcome back, everybody. We are back with Mr. Vandrick's class. Today we are going to do experiments and observational studies. Let's go.
Woo! Let's do it. All right, so here's some information about Chapter 13. In Chapter 12, which we just finished up last week, we looked at all different ways to sample. Okay, we looked at some simple random samples, SRS. Any other sampling methods you guys remember? Any other sampling methods you guys remember? Systematic. Thank you, Natalie. Convenience. SRS is a simple random sample. Stratified, and one more we talked about. Very good cluster, okay? You will need to know and how to identify all of those for the test a week from today. All right? So, let's shift to experiments. All right? And before we get there, I want to show you the difference between a study and an experiment. So when you guys read articles in other classes or just in your daily life, you can determine if someone is talking about a study or an experiment. All right? So we have a couple of different ways we can describe a study. The idea with a study, all right, is that you're just observing something that's happening. All right? No one has been assigned any treatments. No randomization has taken place. You're just observing something in the world and writing down what you observe. Okay, so we have kind of two types that we look at. We have one that's called a retrospective study, where you look at data from the past, and then a prospective study, where you're looking at it as it happens. Okay, so there's kind of two different types for these types of studies. All right, big thing here, though, is you need to know, before the test in 1 week, the difference between a study and an experiment. Any questions about a study? Okay, great. Let's continue. Nope, let's not continue. An experiment. So yesterday with the gummy bears, you guys ran your first ever experiment in this class. Now you guys ran it very poorly, but that's by design. All right, I want you to do it without me guiding you so you can see how terrible you are at it. Okay? In a good way, so you can learn all the mistakes you made. We'll talk about those at the end of class today, after we talk about the information from this chapter. All right, let's keep going. Now, let's talk about experiments. The nice thing about an experiment is if you run it correctly, you can actually make cause and effect statements after. Okay? I'll repeat that because it's very important, and it's what you're writing down right now. An experiment, if you run it correctly, allows you to make cause and effect statements. With a study, you cannot do that. All right, so an experiment allows you to draw those kind of conclusions. A study does not. So a study cannot, because you're not actually randomly assigning whatever your subjects are, your experimental units, to different treatments. You don't have any control groups, so you're not allowed to make any of those statements about cause and effect. It's still impactful. I'm not saying studies are not impactful and can give you a lot of good information to learn about something, but you can't go that next step. Yeah, so if you do a study where you're looking at, this is a great question from Bashir. Did everyone hear the question from Bashir? Can you say it a little bit louder for us, Bashir? Listen. So I think what you're saying is you've seen or read studies about someone being exposed to radiation, and that giving their chance of getting cancer to go up. Okay? Now, ethically, would you think it's appropriate to randomly assign some humans to put them in an area of radiation, right, and others not? So the idea is with that, you can say that there's a relationship, but you can't say that one causes the other. So have you guys ever read things on the internet where someone says drinking a glass of wine will reduce your chance of heart attack, or eating more tomatoes will reduce your chance of getting cancer? Like all those things? All right? All those things are just studies. All right? So they're not true. They're not cause and effect. They're just studies.
So I can eat tomatoes. I'm still
Of course. Of course. Right? All these things are talking about looking at data over time. Right? They're making statements, but there's no cause and effect. So you can't be like, wait, you told me I wasn't going to get cancer, and I ate all these tomatoes. That's not what they were saying. They were saying studies have shown that you have a lower risk of getting it, but you still could get it.
Oh.
I'm not sure. I mean, I'm not a doctor, so don't ask me. Exactly. What else are you controlling, right? Is the person only eating tomatoes? Probably not. There's other factors like your genes, right? I'm talking about your genetics, like your, no, not your genes, like your exercise habits, things like that. So all of it factors in, which makes it hard to make those cause and effect statements. I'm not saying, like, go run around in a lot of radiation this year. I think we all would agree that there's a relationship there. But you can't say the reason that person got cancer was because they were in the radiation. There could have been other reasons why they got it, even if you think that was the main reason they got it. Make sense? We can't prove it because we're not going to send some people to expose them to radiation and some not. That's why they use laboratory rats or different animals like that. That's experiments. So then you could prove it. But you have to go to human trials for humans, which, again, we have that issue of ethics. We're not going to expose humans to dangerous things just to prove something. Yes?
So studies are more open-ended.
Yes. You can make conclusions from studies, but I don't want you to think that those are, like, engraved in stone.
Yeah.
All right? Because someone can find another study that disproves yours. Right? That happens all the time.
Yeah.
Okay? All right. Now, if you think back to yesterday, we had our gummy bears. Remember our gummy bears yesterday? Yes, I do. If you launch the gummy bears, right? Each gummy bear was an experimental unit. Okay? So when it's people, we call them subjects or participants. Otherwise, that just makes people feel weird if you call them experimental units. Okay? So all those things mean the same thing. Experimental units, subjects, or participants. Girls, where were you guys? Oh, gotcha. Did you guys go off campus for lunch?
No, this is for
Gotcha. Does he know when the bell rings? No? Okay. Gotcha. We should get one. All right, I'll just shout, I'll just yodel. You gotta come.
But how would we do that if we're inside?
I'll get a megaphone. I'll get Peter's truck. Doesn't he have like a megaphone in his truck? Yeah. Right? Speaking of Peter's truck, I saw him one time backing into a spot and just knocked a tree over. Just knocked it over. It came back. He pushed it back. It's totally fine. But I was like, Peter, you know, hit that tree? He's like, yeah, it happens.
Wait, were you there at the game where we were going to like the speaker? We were saying something to Mr. Riesenballer Torres?
No, I wasn't. Like through Peter's thing. Yeah. He did it to me across the parking lot. He was like, Mr. Frandrick. I was like, God? Am I having an experience right now? And then he's like, it's just me, Peter. I was like, oh. Yeah, Peter. Now, let's talk about the factors, levels, and treatments. All right, and where you're going to get a chance to use this vocab. You're going to get a chance to use this vocab at the end of class when we think back to yesterday's experiment. What were the factors, what were the levels, and what were the treatments? Okay, on the test on Wednesday of next week. On the test on Wednesday of next week. Okay, on the test of Wednesday of next week, you're going to have to tell me these things that when I give you a scenario. What are the factors? What are the levels? What are the treatments? Okay, what's the response variable? What are you measuring? What were we measuring yesterday?
Okay, we're going to have a test for next week.
What were we measuring yesterday? How far the gummy bears went. Thank you, Listen. Now, let's talk about a test. Let's talk about the 4 principles of designing an effective experiment. The first one is to make sure you have a control. Okay? The idea is you only want to be manipulating one thing. I'll repeat that. You only want to be manipulating One variable. If you manipulate multiple variables at the same time, how do you know what's causing your response or your effect? Okay? We don't know if we change too much. So that's why you want to try your best to only change one thing at a time. Okay? So let's think about that again when we get to the end of class about our experiment from yesterday. All right. Let's keep going. The second principle. You want to use randomization. Now, this is important. I want everyone to listen up. This is important, okay? Because you've had an experience with randomization, with running simulations, those trials, and with sampling. Remember our farmer activity from last week, okay? Now, with experiments, I want to make sure your brain understands when you should be randomizing, okay? You don't, like if I'm trying to figure out if a new drug is effective in curing some type of illness, who do I want to use for my experiment? People with that illness. So you don't want to randomly select people from the population. You ask people for volunteers who have the illness, have been tested positive for whatever that illness is. And then you randomly assign those people to different treatments. That's how an experiment works. Okay? So the randomness comes up when you want to randomly assign the treatment they receive. Lexi.
Is it like a clinical trial?
It is exactly like a clinical trial. Not everyone gets the same thing. Okay?
What if like it makes their illness?
That would be very important to understand if the new drug is making the illness worse. Now, hopefully, before it gets to human trials, it goes through a lot of different steps, like usually rats, and usually they have positive impacts there. So hopefully it's not making things worse. Now, it could have side effects that they didn't expect because you can't see all the same side effects in rats. Right? That's why you hear these commercials for a new drug to try, like side effects may include, and they rattle off like 10 things. My favorite is when they go, and sudden death. And I'm like, well, good, let's take that drug.
And then it's like the grandpa rustling
Yeah, right?
over a sunset.
Yeah, try Lunesta.
Then like it's a guy that just eating a burger and they say this off like vomiting, nausea.
Yeah, and you're like, I really want that burger now. Now, the third one. The third one is replication. The third one is replication.
Replicate that movement.
Exactly. If you get a positive result, all right, if you're testing this new drug and humans in Houston give you a positive result, let's replicate it somewhere else different. Right? I'm thinking of a very different place like Denver, because Denver is a very different altitude, different climate. So maybe that has an impact on the results of this new drug. Okay? So you want to replicate somewhere else, either in the country or the state or in the world, to see if you get the same types of results. Okay? That's replicate. All right? So if you're reading anything, on the internet about the results of an experiment, hopefully they've been able to replicate those results in multiple places. Yes.
So, the treatment of the illness. So, when you replicate it, you're not just replicating the one that works.
Exactly the same. You want to run it the same. You don't want to change anything because then you don't know if it's because of the location and the people or something you changed. So you don't want to change anything. Hopefully. All right, the fourth thing. Now I want to be clear. This fourth thing called blocking is not required. I'm going to repeat that. Maybe put a little note there or underline it somewhere. It's there. It's not required. The other three steps are required for a good experimental design. And some of you out there, even if you don't know it yet, will take a course in college called experimental design. The entire course is about this stuff. All right, obviously more in depth, the whole thing. Everything we're talking about in this chapter, the whole course. Okay? So blocking helps you reduce variation in some kind of variable that you're trying to control. Like, for example, what if the drug that we're trying to see if it works, what if men and women respond differently? What if men and women respond differently to the drug? Then we want to block by sex and have basically what I call two types of experiments. You're doing two virtually the same experiments, but for men and for women. Okay? So that's my big thing for you guys when you think about blocking. The way you want to think about blocking is it reduces variation, and it's a way for you to run the same experiment to control that variation. I will be asking you questions about blocking on the test.
So we just put not required.
It's not required, yes. But if you know that something out there, Shyla, is going to affect your results, you should do your best to block based on what that is to reduce that variation, that change.
Can you give us the, can you like do that with the example of girls?
Yeah, with the men and the women. So you would say, like, if men and women react differently to the new drug, okay, then I'm going to say, okay, if I get 50 volunteers and 25 are women, 25 are men, then I'm going to randomly assign those 25 women to my different treatments and then randomly assign the 25 men to those different treatments and look at the results from both. Because if I don't want to have any issues with the crossover of that. I'm blocking based on sex, so that way I don't get all men or all women get one of the treatments. Yes? Go for it. Now, this is a quick little blurb, but this is going to be super important next semester. Okay? And some of us just missed that. This is a quick little blurb here, but you're going to hear this a ton in the second semester, and that's called statistically significant results. So if you are reading a report or an article about the results of an experiment, and they use the phrase statistically significant results, that means something happened in the experiment that was more than just chance or random variation. Now, the hardest thing for us as statisticians is understanding where we cross that line into, you know what? I don't think this was just randomly happening. I think this is something happening according to my treatment. So I'm going to say the drug is effective. That's the hard part with clinical trials, is because if they want to get it to market and sell it to people, they need to make sure that no one's going to die. They need to make sure that it actually is better than what's currently available. So that's what's really difficult about finding these statistically significant results, because it's based on the context of what you're doing. And again, this is a quick little blurb. We're going to talk more about that and how to do it mathematically next semester. Now, quick little thing here about experiments and samples and how they're different. This is chapter 13 versus chapter 12. And I already mentioned this. With experiments, I want a certain type of subject or person. Okay, like with the illness. I want someone who is actually sick with that illness. With samples, I'm randomly selecting from a population a good representation for that population. So we use sampling to make estimates about what's going on in the population. With experiments, I want a certain type of subject, and then I randomly assign them treatments. Okay, so it's a little different. All right. Now, control. If you don't have a control, it's going to be very difficult to prove statistically significant results. Okay? So you always want to try to have a control group. And one way we do this, all right, is to make sure we try to have a group where they call it a baseline. All right? If I'm testing a new drug, I want to make sure to give some of those people a fake drug, nothing. Or some of those people, I want to keep giving them the current drug they're taking. What if they're all already taking a certain medicine? Keep some of them taking the current medicine, give some the new medicine, and see what the difference is. Okay? That makes sense? You want to have a control group, something to compare to. That's where that comparative word comes from. Compare your results to a control. Say it again. It's illegal? What's illegal? Anyone doing this is volunteering to get paid. So no, it's not illegal. You sign something that says it's not. They sign, dude, and they sign everything. Legally can't do diddly. Well, they should. Now, have you guys heard of the term blinding when it comes to experiments? No. All right, so the idea here is, if I'm being treated for this illness, okay, and a nurse walks in, and he decides to give me a certain treatment that they've randomly assigned, what if he's like super happy with me and like we're just talking about everything, we're like super excited, we're having a great time, but then somebody else, that same nurse walks in and they're very sad and depressed and they're really mean, and they're like, what? Are we going to have different results about the drug? Maybe, because that person might know which one of us is getting the preferred drug, the one they're trying to prove. So you want to blind, and I don't mean like physically blind them. You want people involved in your trials to not know who's getting what. Okay? You don't want anyone to be biased to think, oh, they're getting the new drug. I think they're going to have better results because they're getting the new one. You don't want that. You don't want anyone to know. Now, someone has to know, right? We can't have no one know. Someone has to know, but you don't want them to have any influence on the results. They should just be analyzing the results. Okay? So that's called blinding. There's single blind and double blind. You want to try to get double blind experiments where no one knows that's involved in the actual distribution of the treatments. Well, somebody knows, right? The person running it. But like the people taking the pill they don't know. The people administering it don't know. The people asking them, how do you feel, don't know. But the person who looks at the results at the end, I mean, they're going to know. Well, ultimately, you want to see if it worked. Now, say it again? Yeah, at the very end. That's when they do it. Now, there's one way to do this when you're talking about drug trials, and that's with a placebo. All right? You may have heard of this thing called the placebo effect. Not gazebos. The placebo effect.
I know there was a gazebo worth more than the soul cost.
Okay, the placebo effect is when someone is given a drug, but the drug the pill doesn't actually contain any medicine, and they feel better because they think they did. That's called a placebo effect. So in experiments, when they do these clinical trials, they give them sugar pills. All right? So the pill looks exactly the same, but it's not filled with any medicine, it's just sugar.
What if they're diabetic and you give them the sugar?
Okay, I mean, obviously they wouldn't do that, Natalie, right? That's why you fill out all your forms. A long time ago, I don't like scary movies, so I don't want to talk about it.
You should change that tonight.
talks about the little kid, he's like,
There you go.
Well,
There you go.
Why he pronounces them as gazebos?
Does he?
Yeah.
Okay. Now, the best experiments contain these four things, if possible. So I'm going to repeat that. The best experiments contain the fact that you've randomly assigned your treatments, you have a control group, that's the comparative piece. It's double blind, no one knows who's getting what, and you have possibly a placebo control group. All right? All right. Now, back to this word blocking. I know. Back to this word blocking. Do you guys remember when we did a stratified sample with our sampling? No, you guys remember stratified? Remember with the farmer one where we stratified based on vertical columns and then horizontal rows? Stratified is where you choose a little bit from each. A little bit from each group. That's stratified. The idea with blocking is that blocking is to experiments as stratifying is to sample. Okay, so you can think of them as comparable, but one is for experiments, that's the blocking, and the other is for sampling, that's stratifying. All right, we also have something called a match pairs design. If two people get matched and compared, like everything is the same, like one of the examples they love in standardized tests, if they look at women over the age of 50, and they're looking at it's the same kind of woman, except for one exercises and one doesn't. Okay? And they want to look at the results between the heart attack rates in those women. So they matched women together to compare them, trying to keep everything else the same, whether that's possible or not. That's called a matched pairs design.
Wait,
All right. Yes?
So these don't have so do we make them get a heart attack?
No. That would be a way of doing it with a study. So like I'm observing these women, and I'm not trying to induce any heart attacks here. I'm looking at over the next 15, 20 years, if one woman gets a heart attack, like one group of women gets a heart attack over the other. But I'm trying to keep everything else the same, so I match them with a woman who's similar, except for that one thing I care about, exercise. So they have the same diet, they have the same other health issues, like don't have high blood pressure, they don't have high cholesterol, like everything else I try to keep the same. Okay. All right, the last thing. Confounding variables. Do you guys remember that term from Unit 1? Or no, it's actually Unit 2, called lurking variables? Do you remember my example where I was looking at the average life expectancy and the number of TVs in countries? And we looked at the more TVs a household had, the higher life expectancy was in that country. And so we were like, oh, we should send TVs to these countries with low life expectancies.
Oh, wow. Yeah.
Does that make any sense? No. And we said there was a lurking variable, and that was the actual socioeconomic status of that country. Because wealthier countries usually have better healthcare systems. Usually. Right? U.S. notwithstanding. Okay? That was a shot at the healthcare system. That's what that was. Right? Right across the bow. Actually, right into the bow. Right into it.
Oh no, they don't.
Right? Vote. Vote.
Vote.
That's not in their health plan.
Healthcare sciences.
Vote. I did. Vote when you become 18.
We're probably.
Thank you. I appreciate it. I walked out and I thought, man, I'm so proud of myself. You should. Are you 18? Yeah. All right then. Before November 6th. Sad. Don't worry. You got many more. Many more. I love it. I love it. It's a good offense. Okay, so the other word we're talking about in this chapter is confounding. So this is where you have a factor or a level of your factor in an experiment gets mixed up with another one. All right, and then they can't separate them out. So let's say we find out after the fact that men and women react differently to this new drug. And we're like, oh, shoot, I wish we would have known that before, because then I would have blocked. But now we have an issue because the sex of our patients, okay, men or women, that is impacting our results. So we have confounding variables now. We have their sex and whatever we're testing, their illness. Okay? All right, so let's go ahead and stop.
And that is all for today. Thank you for joining us. Next time, tune in with us. Let's go.
I want you to